Hey, what's up, guys? It's Mr. Ernst, and we are at state cross country today. And so I'm just going to give you guys these notes via video. Hopefully the test went well yesterday. You should be getting those back on Monday. We are going into a conic sections chapter. That's our next unit before Thanksgiving here. And so we start the day with circles. And so you guys have seen the definition of a circle on multiple occasions. When we're talking about circles, we are going to be talking about circles in the coordinate plane. And so our circles are going to be centered at a point called h comma k. The circle is a set of all points x comma y in a plane that are equidistant from a fixed point h comma k, called the center of the circle. And so obviously the circle is there, and R is known as our radius. Okay, and so basically a circle is just a collection of a ton of points that are all the same distance from that center point h comma k. So that's the piece that you're very familiar with. Okay, and now moving the circle around, the standard form for the of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. H comma k is the center of that circle, and the positive number r is the radius of the circle. The standard form of the equation of a circle whose center is at the origin is simply x squared plus y squared is equal to r squared. So this one's at the origin, and this one is anywhere that is moved away from the origin. Okay. So example number one, the point 1 comma negative 2 lies on the circle whose center is at negative 3 comma negative 5, right? The standard form of the equation of a circle. First thing that I would recommend that you guys do on these is just draw yourself a quick picture. And so the center of our circle is at negative 3 comma negative 5. Okay, so center negative 3 negative 5, and the point 1 comma negative 2 I should say lies on that circle. Okay, and so we basically know that our circle is going to be this guy right here. Obviously, that distance from negative 3, negative 5 to 1, negative 2 is our radius. And so in order to find our radius, we're actually going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and so this will be able to tell you your radius. I'm actually going to call that d being distance, but in our case it's going to be r. And so let's scoot over here to give ourselves some room. So in our case, our radius is going to be equal to, we'll take our x coordinates 1 minus negative 3 squared plus negative 2 minus negative 5 squared. You could do that in any order you want. It'll work out the same. But 1 minus negative 3 is 4 squared plus, the lights just went off in the room. Let's get that back on. Hold on one sec. Plus, that would be a plus, so 3 squared, which is equal to the square root of 16 plus 9, which is the square root of 25. So our radius is equal to 5. Our center is at that point. Those are the only two pieces that we need to know to find the equation of a circle. And so given that those are our center and radius, our circle is going to be x, plus 3 squared plus y plus 5 squared is equal to 25, because it's going to be r squared right there. Okay. So the second one down here, very similar idea. The center is once again in the third quadrant, -2, -3. The point 1, 4 is right there. We know that our circle is going to be x, because the center is at -2, -3, plus 2 squared plus y plus 3 squared is equal to blank. And we just need to find r, that radius. And so there's our circle again. R is going to be equal to, in this case, the square root of 1 minus -2 squared plus 4 minus -3 squared. And that actually works out to be 3 squared and 7 squared and a square root, which will end up being 9 plus 49 square rooted. So our radius this time does not work out nicely. Our radius is the square root of 58, which is kind of a nasty number, but the good news is this is, as you can see above, r squared, and so it's just going to be equal to 58, okay? And thus, there is the standard form of our circle. Flipping it over. On the back side, it says, sketch the equation given by this circle. Now, here's the issue, is that doesn't even look like a circle. And so this is where completing the square comes into play. This is a circle. We just have to reorganize it and make it decent. And so if it doesn't look recognizable as a circle, what I want you to do is I want you to group together the x's. So x squared minus 2x plus blank plus y squared minus 4y plus blank is equal to, and we're going to add that constant to the other side, so plus 4, and I'm going to put plus blank over here, because we're going to have two different values that we need to complete the square, okay? Because we know that a circle is going to be an x perfect square, a y perfect square, our goal is to get these two to be written as perfect squares so that we can write it as a circle. And so we do the normal thing that we always do when we are completing the square, and that is we take negative b, or not negative b, just b over 2 squared, okay? So that's -1 squared, which is 1. That's what goes in here. We'll make sure we add that to this side. For the y, we take the b value over 2 squared, which is -2 squared, which is 4. And we add that, okay? And now we have our perfect squares. Remember that your perfect square will always be that number after you've divided before you've squared. So our first one is x minus 1 squared. Our second one is y minus 2 squared. And if you add 4 plus 1 plus 4, you obviously get 9. Okay, so this works out really nicely. Our center of this circle is at 1, 2, and our radius is equal to the square root of 9, which is 3. And thus, when we graph it, 1, 2, 3, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4. Label those guys, 5 and 5. Our center's at 1, 2, and our radius is 3. Count up 3, count right 3, count left 1, 2, 3, count down 1, 2, 3, and then just do your best to round that guy off and make him a circle. Okay. Second one, very similar. Group the x's. X squared plus 6x plus blank plus y squared minus 2y plus blank. Let's move that 6 over, is equal to negative 6 plus blank plus blank. Complete our square. 6 over 2 squared, 3 squared is 9. Put that in there. Here, complete the square of the y. Negative 2 over 2 squared, negative 1 squared is 1. Okay, put that in there, simplify everything. Again, the light kicked off. Come on. X plus 3 is our front one. Kick back on light, thank you. So this is x plus 3 squared as a perfect square plus, that second one is y minus 1 squared. And if you add all of these values together, negative 6 plus 9 is 3 plus 1 is 4. So our center is at negative 3 comma 1. And our radius is equal to 2 because that's radius squared. So if we graph negative 3 comma 1 is our center, and our radius is 2, up 2, down 2, left 2, and right 2. And just connect your dots. All right, and our very last one. Find the x and y intercepts of the graph of the circle given by this equation. First things first, let's draw a picture. Our center is at negative 2 comma 1 because of those guys. And our radius is the square root of 10. Okay, so center negative 2 comma 1. And our radius is root 10. You're looking at this going, okay, this is interesting. How am I going to do that? Well, the good news is this. Just like it's... Oh, yeah, that wasn't good. Always has been in the past. If you want to find your x-intercept, y equals 0. To find your y-intercept, x equals 0. Okay, so we're just going to take that equation, plug in 0 for the y to find the x-intercept. So we get x plus 2 squared plus negative 1 squared, because y was equal to 0, is equal to 10. We need to solve that equation to find our x-intercept. And for the y-intercept, you plug in 0 for the x. So you get 2 squared plus y minus 1 squared is equal to 10. All you have to do is solve those equations, which is going to mean that you square that, you get x plus 2 squared plus 1 is equal to 10. Subtract 1 from both sides. Y plus 2 squared equals 9. We'll square root both sides and solve. And down here, 4 plus y minus 1 squared is equal to 10. Subtract 4 from both sides. Y minus 1 squared is equal to 6. Square root and solve that. And you're actually going to have 2 x-intercepts and 2 y-intercepts for each. For the x-intercepts, the solution to that equation, y plus 2 squared equals 9. When we square root, don't forget, plus or minus. Now subtract 2 from both sides. And our y-intercepts are going to be, if it's 3 minus 2, you get 1. If it's negative 3 minus 2, you get negative 5. Those are our 2 y-intercepts. For our x-intercept, we're solving this equation. Y minus 1 squared is equal to 6. Square root. y minus 1 equals plus or minus root 6. Add 1 to both sides. Our y-intercept is not quite as nice. P.S. That was supposed to be x. X-intercept, my bad. Y-intercept is going to be 1 plus or minus root 6. Okay. Monday when I get back, we will be able to look over a little bit more of this stuff. But hope you guys have a nice weekend. Thank you for taking notes. Your homework's out of the book. It's on Haiku. So have a good one, guys. See you Monday.